Hi, my name is Jacob Racusin. I'm with Builders for Climate Action, and I'm excited to share the Beam tool with you. So the Beam tool helps reduce the embodied carbon footprint of your building by looking at the material carbon emissions of your project and helping to reduce them. You can do this by doing side-by-side comparison of individual materials and their carbon emissions, comparing full building assemblies and the emissions of those assemblies, or even looking at whole buildings and the entire building's worth of materials and doing direct comparison across projects to figure out where improvements can be made to reduce the embodied carbon of those building materials. We've designed the tool to be easily used as a design aid, as well as a procurement tool to dial in on the best possible material selections for your project. We've ensured bringing in a wide variety of innovative and carbon storing building materials into the palette that's available within the tool. So this tool is explicitly a material carbon emission estimator, the A1 to A3 phase of the building life cycle, also known as the cradle to gate phase. So this tool works great standalone if you are looking to analyze the material emissions of your project. It also works as part of a tool stack if you are doing life cycle assessment and providing features and benefits of the tool that can't be found in common LCA tools. So the methodology for the Beam tool, such that the emissions from your materials are accounted for, sourced from EPD or Environmental Product Declaration data sources for either individual products or for averages of materials from industry trade groups. We are also looking at the biogenic carbon storage, or the bio-based carbon stored in these materials, and where it is validated, that is removed from the gross emissions and leaving the net emissions of material carbon impact. And all of those numbers are fully disclosed and explicit throughout the tool. So the tool, unlike a BIM model tool, has an area-based input structure. So not unlike a box model for an energy model, you are putting in the basic areas and dimensions of your building assemblies as the primary input for the tool. And then as a spreadsheet-based tool, you work your way along all the different tabs of the spreadsheet, which represent the different primary assemblies of the building. And within those tabs, in this case, we're looking at the exterior wall tab. You may put in an additional input for certain features, such in this case, we need the R value. And then all of the materials, in this case, within the cavity insulation category, are all organized by material type with both industry average and individual product represented within the tool. And you can immediately at a glance do direct comparison of the net emissions of the material as well as the gross emissions. And then for their material storage available, you would see those in these categories as well. And by simply checking a box, you can add that material to your subtotal, which is shown at the top of every page. You can work through as many or as few of the different parts of the assembly as you like. If you're going for a full building, you could fill out all of the sheets. If you are just looking to do a study, say on a wall assembly, you could just stick within that tab. Add whatever additional data inputs are required within those various parts of the page. And that is what is required for getting all of your data in place. I mentioned that carbon storage is a core part of the tool. And so in looking at that, you'll see we break that into both short cycle and long cycle carbon. Short cycle refers to materials that are purposed out of the waste stream or come from residue materials or annual or short cycle, like less than 10-year agricultural products or products that can effectively store bio-based carbon in the building material, where otherwise it would go through its end of life phase and be re-aerosolized into the atmosphere. We separate those out from virgin wood products, which are much longer lived as a species and part of more complex ecosystems, where the counterfactual scenario of being used in a building may be that it continues to photosynthesize as a tree in the forest. So we give the option to select those if you can validate the management practices of the forest and can control for your sourcing in that way. You can review all of the materials you've selected, which is a terrific feature for both quality assurance and quality control, as well as making it easy to be able to pull this data into a separate spreadsheet for post-processing, and gives you an at-a-glance look at the most carbon-intensive materials within your bill of materials that you've selected. We then have a share page in which the data from and the results from your analysis can be shared with your project team, including the intensity on a per assembly basis, seeing where the pools of emissions are in your project, looking and reporting about the net emissions and the material intensity per conditioned floor area, total floor area, or per bedroom, with a relative scale of impact compared to baseline averages. We give a profile of the highest emitting materials, as well as the ability to compare across multiple different scenarios to look at a baseline and an improved scenario within a given project type. You can use Beam at the very beginning in the schematic phase to rough out dimensions and look at basic, basic early design impacts of design decisions. In design and development, it's hugely valuable for comparing different assemblies and doing material selection, and as well, of course, during CDs and procurement when we're looking to get as product specific as possible to ensure the best possible outcome for your project. We'll see you at an upcoming training, and go ahead and download this free tool using the QR code. Let us know how you find it. Thank you for your time.